Hey there, burning a lot of calories today?
Well, it says right here, but I don't know what this number means. Is it a lot? Why does it matter?
Whoa, 1 calorie. Well, it actually tells you your energy expenditure from this workout. You might care if you want to lose weight, for example.
I actually don't care about losing weight. I just want to have as intense a workout as I can. Does this power output tell me anything about that?
Well, it's actually the best indicator for the intensity of your workout. It tells you how much work you're doing during your exercise.
So I see that I've burned 500 calories.
Whoa.
But how do they measure this? Do you know if it's accurate?
Well, it's not a direct measurement, it's actually an estimation based on formulas. So, let's see how this really works.
Almost every piece of cardio equipment you find in the gym can tell you how many calories you burned during your workout. So what are calories? A calorie is the amount of energy needed to raise the temperature of 1 gram of water by 1 degree Celsius at a pressure of 1 atmosphere. More commonly, you will see the kilocalorie, the unit associated with food, which is 1,000 calories, or the amount of energy needed to raise the temperature of 1 kilogram of water by 1 degree Celsius. Cardio exercise machines, such as treadmills, ellipticals, stationary bikes, and rowing machines, can tell you the caloric expenditure, how many calories you burned during your workout. People care about their caloric expenditure as it is relevant when you want to manage your weight, optimize exercise protocols, or provide exercise prescription. If you were to directly measure caloric expenditure, you would have to measure the heat released. Since this would be a very complex measurement, oxygen uptake is used in lab settings as an indirect measurement for caloric expenditure. Oxygen uptake relates to calories burned. A VO2 of 1 liter per minute is equal to 5 kilocalories per minute. This relationship comes from the following chemical equations. The respiratory exchange ratio is a number derived from oxidation equations of the molecules we use for fuel, carbohydrates and fatty acids. The RER is the ratio of carbon dioxide produced to oxygen used in the metabolism of one molecule of fuel. As you can see, the production of ATP, which is a measure of energy expenditure, is related to oxygen consumption. This table represents the energy expenditure for different respiratory exchange ratios, and the number 5 kilocalories per liter of oxygen corresponds to a metabolization of mainly carbohydrates. Because we do mainly rely on carbs for energy, 5 kcals per liter O2 makes for an appropriate value when making calorie expenditure estimations. Cardio machines use mathematical formulas to estimate oxygen consumption, which is then converted to caloric expenditure. The oxygen consumption is estimated in milliliters per kilogram per minute. So if you input your weight into the machine, it will convert this to milliliters per minute, the volume of oxygen consumed per minute, which can then be converted to kilocalories as mentioned before. If you don't input your weight into the machine, it will take an average value. Here we will show you how a treadmill, bike, and rowing machine use formulas to estimate caloric expenditure.
The treadmill uses formulas that are empirically derived by the American College of Sports Medicine. It uses one equation for walking, which is defined as up to 4 miles per hour, and a slightly different one for running. The VO2 is measured in milliliters per kilogram per minute. The speed is measured in meters per minute. The 0.1 refers to the oxygen cost per meter of moving each kilogram of body weight while walking horizontally. The 1.8 refers to the oxygen cost per meter of moving total body mass against gravity, so vertical movement. The 3.5 is a constant that refers to the resting oxygen consumption. For running, a slightly different formula is used. As you can see, the values for oxygen cost of moving the body horizontally and vertically are different. 0.2 for horizontal and 0.9 for vertical movement. For biking, they use the formula to estimate caloric expenditure. The VO2 here is 1.8 times the work rate divided by the body mass in kilograms plus 7. 1.8 here refers to the oxygen cost of producing 1 kilogram meter per minute of power output, and 7 refers to the oxygen cost of unloaded cycling plus resting oxygen consumption. The work rate is another word for power output, which is something that is predetermined during manufacturing. However, we will quickly explain what the power output on a bike means and how you would calculate that. Remember that power equals the work times the time, where work is force times distance. In the case of the bike, the force is the friction resistance provided by a belt around a flywheel. Tightening this belt provides various levels of resistance. For example, you could determine the power for these values. If the resistance is 3 kilograms and you cover a distance of 6 meters per revolution and your speed is 50 revolutions per minute, the power output will be 900 kilogram meters per minute. Remember that kilogram meters can be converted to Newton meters, which equals 1 joule, so you can get joules per second as the power output units. However, as said earlier, for bikes the power output for various resistance levels is determined during manufacturing. The bikes are affixed to a dynamometer, which is used to measure torques on the drivetrain. This dyno is able to measure and record the actual power output in watts, which is joules per second. These output values are then stored on the bike sensor control board to be assessed during each ride. Each bike is equipped with Hall effect sensors for measuring flywheel rotational speed and resistance. The sensors reference the output values on the sensor control board and communicate these values to the bike's touchscreen multiple times per second during a ride. Now for a rowing machine, the power output in watts is calculated using the following simple formula. The amount of watts equals 2.8 divided by the pace cubed. 2.8 is an empirically derived constant, and the pace is equal to time in seconds over the distance in meters. For example, a 2 minutes and 5 seconds over 500 meters split would equal 125 seconds over 500 meters or a 0.25 seconds per meter pace. Watts are then calculated as 2.8 divided by 0.25 cubed, which equals 179.2 joules per second. Similar to other cardio machines, rowing machines calculate the calories burned based on formulas calibrated for a certain average size of person and then applying a correction factor based on the user's real weight.
Even though these machines give an indication of how many calories you burn during your exercise, there are various limitations. Both the calculation for calories burned from exercise and the estimation of calories burned due to your resting metabolic rate are not 100% accurate. For example, estimations do not take into account what your body composition is in terms of muscle mass and fat ratio. If you have a higher muscle mass and lower body fat percentage, your resting metabolic rate will be higher. It also doesn't account for movement efficiency, and it does not distinguish between carbohydrates and fatty acids as a source of energy. During shorter, intense workouts, you rely more heavily on carbohydrates, but for workouts longer than 60 minutes, you'll start using more fatty acid, which use 4.73 kcal per liter oxygen instead of 5.05. Even though the cardio equipment cannot take all these factors into account, it will still give you an approximate value of calories burned. To get the most reliable estimation, make sure you always put as much information as possible.
But remember, life is not all about calories, so enjoy your workout, eat a cupcake, and be happy.